Alright, welcome back guys, nice to see you again, and here we're going to be looking at neutralization reactions in everyday life. And so here's the syllabus point we're looking at here. Okay, it says we're going to investigate applications of neutralization reactions in everyday life, and then there's some industrial processes. So we're not going to cover the industrial processes here, but I do encourage you to go look at the Solvay process, and the Solvay process is where you make some sodium carbonate, which have found a lot of things such as soaps and detergents and washing up liquids and stuff like that. So go check that out. Find a flow diagram because they sometimes can challenge you with those sort of questions. I know in the last syllabus they had the industrial chemistry section and they looked at the Solvay process was in the industrial chemistry section. So go check those ones out. But try and identify the step of neutralization in those flow diagrams. We're going to be looking at, of course, everyday examples of neutralizations. So let's get to it. Alright, it's getting summer now and you have very hot temperatures and most people love to jump in their swimming pool. But of course the chemistry of the swimming pool must be right so that it's nice and safe. We've got to kill germs that enter the swimming pool, okay? But at the same time, the chemistry that kills the germs, we've got to try and ensure that our eyes and other mucous membranes around our body and our skin aren't adversely affected. And so let's check out some pool chemistry here. So we've got some sodium hypochloride, right? Hypochloride. The prefix hypo means below, and if you were to say hyper, it means above. So in chemistry, we're using hypo to indicate this group here, hypochloride, and that's just a naming convention that we didn't really get into when we were naming acids and bases before, but just that's why it's called hypochloride. Now here we have sodium hypochloride. It can dissociate into sodium ions and the hypochloride ion, but that ion there then reacts with water to produce hypochlorous acid, and it's the hypochlorous acid that goes along and kills our germs. Okay, so that makes the water nice and safe. But not only does it make it safe, it also produces an OH- ion. So the pH of the water starts to become more alkaline. And that alkalinity of the water is what can cause the problems with our eyes. So we've got to try and keep this hydroxide ion under control and so we can stop this redness. So let's see how we do that. So we do that by testing the pH of the pool very frequently. And so here you can see here we've got an indicator here called phenol red. Now with phenol red it has a certain range of colors depending on the pH, like all indicators, okay? So it's yellow in acid, it goes through a series of yellow colors, and then it eventually ends red in base. And we want an optimal pH range of around about 7. Okay, so neutral 7 is the way to go. That's the pH of our saliva, etc. So we want to have a neutral pH. So what we do is we test the water frequently and adjust it accordingly. So here you can see a video of the students testing it in the lab. They've got a pH test kit and they've got some pool water, right, donated from one of our students. We're going to see what the pH is in her pool. So they're putting it in the pH. They're adding in a couple of drops of phenol red and then they're mixing it and comparing it to the color chart. And then what pH was it?
8.2.
Okay, it turned out to be around about the pH 8.2, which is too basic. So we've got to bring this down in pH. And so how do we do that? Well, we can add some hydrochloric acid, and that's going to neutralize the base and bring the pH of the water down. Now check this out here. You can see I've got a reaction there. Now what's this hydronium ion over here? Well, in junior school we write dissociation equations like this, but H+, that's a proton. That's way too reactive just to be sitting around in water or in other solutions. So it doesn't really happen like that. It's a bit more complicated. We have water. So what we do now is we say, okay, HCl plus water. That's going to then, what's going to happen is that hydrogen is going to go onto the water there to form H3O+, which we call a hydronium ion. And then we have Cl-. And so this is what this H3O+ there. That of course reacts with any excess OH- that's produced from our reaction we saw before, and that's going to neutralize it. Now of course this here is a protonation reaction, where we basically say it's a proton being added to there, but in reality we know it's not. But we are neutralizing it, and this is an exothermic reaction. Right? It produces heat, and we're going to explore that concept in the next video when we measure the enthalpy of neutralization. So stay tuned for that. So this is how we kill germs, but also adjust the pH of the pool to keep it nice and neutral. Well, what about pH of the soil, I hear you ask? Because I know there's a lot of gardeners out there, and the thing is that plants need a certain pH in order to be effective in how they move nutrients from the soil into the plant. Biologists who study biology, you guys, will know that these transport mechanisms to move nutrients into the plant are an active mechanism, and in order to do that efficiently, sometimes there has to be a certain pH value. And so hydrangeas are one classic plant that we can change the pH with to get a more of a, how could you say, aesthetic appeal, right? So we can change the color of the soil. If we make it very acidic, we get a blue flower. If we make it neutral-ish, well, not neutral-ish, if we make it more neutral compared to the blue, I guess, because neutral's 7. But if we make it more basic, goes up to purple, it's getting late. And then if we make it up to pH 7, it's getting more pink in color. So we can add, if you go to Bunnings and check out what they've got there to add to the soil for our hydrangeas, you can get specific packets to make it more bluer or to make it more pink, and that just adds different amounts of acid or base. So let's check out some reactions here. So we can change the soil and make it more acidic if we add the compound ammonium sulfate. So let's check out what's happening. We have ammonium, and it's a sulfate, so there it is. Okay, now if we let that dissociate, we would get ammonia, and we would get sulfate. Okay, but we mix it with water, don't we? Well, the sulfate doesn't really do much because we're going to learn that it comes from a strong acid, completely dissociates. So if we put that in water, we're just going to have sulfate ions, that's it. But a curious thing happens with our ammonium though, if we add that to water. If we add ammonium to water, we get this reaction happening. There's the water, and it's an equilibrium reaction. What happens is that H plus goes off over to there, that gives us ammonia, and then we end up with a hydronium ion. So there is our H plus ion that's going to make the soil more acidic, because that's what we do for more acidic. Well, what about our calcium carbonate to make it more basic? Well, let's check that out. If we have some calcium carbonate, that will dissociate to give you calcium, 2+, and some carbonate ions. Alright, so calcium is just going to sit there in the water if you put it in water, but the carbonate, something weird's going to happen with the carbonate. And this is what happens. So you have some carbonate, like this, we've got some water, and then what happens here is a H plus comes from the water, joins onto the carbonate, and so then we end up with HCO3 minus plus OH, right? Because once you lose that H plus there, we have OH left. And so there is our OH minus ion that makes it more basic. And so we're going to come into contact with these again, okay, these types of equilibrium reactions that are based on acid and bases here, because we're going to be looking at how you can write those, how you can identify those. It's all to do with the pH of salts and weak acids, and we'll talk more of that in the coming sections. So that's how you change the pH of the soils. Well, what about stomach acid? Well, when you produce excess amounts of stomach acid because you're nervous or because you've eaten too much, that can have implications and give you heartburn. So in the lining of your stomach here, you have cells into our stomach, and of course that's used by pepsin and a lot of other enzymes to break down food. So if we produce too much, however, that goes up to our sphincter and up and into our duodenum here, into our esophagus. Duodenum's down here, and to our esophagus. Now, esophagus hasn't got a lot of mucus producing cells, and so therefore the cells get eaten a little bit by the acid, and therefore we feel that pain, that burn. right? And so we want to neutralize that burn, and we can do that by taking antacids. Antacids have weak bases in them, and so you can see here I've got some heartburn Harry here. His stomach's not feeling very well, so we've got some acidic stomach juices going on there. That's why it's red. But when you add some enos, it produces that bubbly carbon dioxide effect and reduces the pH a little bit. It goes from red to orange. We're not taking it all the way back to neutral, we're just getting rid of the excess acid, because remember, you're adding a weak acid to a stomach contents that has strong acid. So you're just changing the pH slightly to neutralize that excess acid. In fact, you're only neutralizing the acid that's up here to relieve the heartburn feeling. You're not going into this section here to try and decrease the whole pH contents of the stomach, which you can't do anyway, right? Because the stomach's always producing more HCl. But we can also add other antacids and mixtures as well. So here you can see there's some Gaviscon. Gaviscon does a variety of things. Not only does it neutralize the acid a little bit and makes it more orange, but it also soothes the side of your esophagus. But it also does something else. Have a look at this video here where we're adding some Gaviscon into HCl. As you can see there, it makes these stringy worm-like materials that floats to the top. Well, this is called making a raft. Okay, so if I enlarge this here, and if Gaviscon goes up there and makes a raft, it means that the acid now cannot go up into your esophagus anymore, and so that prevents your heartburn. Okay, so that's a pretty cool reaction there. It's a complex reaction where you have something called alginate. Alginate, is a very long polymer derived from seaweed, and the chloride ions in the HCl, those chloride ions act as complexing agents to join the long strands together to make this raft. So it's pretty cool. So there's some examples of common everyday acid and base reactions to produce neutralization reactions and a variety of things. I challenge you to go and now actively recall this content, write out your equations. That's what you should be doing all the time, every single day, right? Take 2 minutes, 5 minutes on the bus ride home. What did I do today in chemistry? And see if you can actively recall it. That's how you're going to memorize it, right? Testing your friends when you're walking up to the shop to buy a drink, always testing. That's the key to frequent revision. Make sure you watch the videos that I've also put up in the study section, which look at things such as making timetables, the best way to study according to research, how do you take active notes, active recall information, heaps of things. See you in the next video. Right, before we go to the next video, I want you to check out more courses that we have here on our YouTube channel, which are just small snippets from the actual bigger courses that we have on theflipteacher.com. Of course, with all of our courses, we try to incorporate practical sessions. We have study cards, we have posters that you can print off and stick around your room and do a lot more. We have up to 68 or more videos per course. That's like 9 to 10 hours of material that really delve deep into the syllabus and looking at essential content, skills, mathematical manipulations, and a lot more. So if you like that, go over to theflipteacher.com and check it all out, and I'll see you in the videos.